Hey there, and welcome to this explainer. Today we're going to attempt something absolutely massive. We are going to tell the story of everything. Earth is 4.5 billion years old, and that number is just so staggeringly huge that it kind of barely means anything to our human brains until we break it down. People usually think of Earth's history as just this dry, boring list of geological dates, right? But it's really not. It is a gripping, intensely violent, and dramatic biography of survival. It's a sequence of chapters, and each one is stranger than the last, building step by step toward the reality that you are living in right now.
I mean, just look at that number. 4.5 billion. Really let that scale sink in for a second. Our central question for today, the real hook here, is this. How exactly did a hostile, molten ball of magma tumbling through empty space become the lush, oxygen-rich world you call home today? Basically, how did we get from fire to forests? Well, let's find out.
Okay, let's jump right into this deep timeline, starting at the very beginning, 4.5 to 4 billion years ago.
Chapter 1, A World Born in Fire. This is the Hadean Eon, named after Hades, the Greek underworld, for a very good reason. Early Earth was an entirely unrecognizable hellscape. We're talking no oceans, no continents, and zero breathable atmosphere. Our planet was just a churning, volatile ocean of magma. Temperatures across the globe were literally high enough to vaporize solid rock.
And this brings us to our first massive cause and effect moment. Right around 4.5 billion years ago, a Mars-sized planet named Theia smashed directly into our young molten Earth. This collision was so incredibly violent that it partially melted both planets and flung immense amounts of debris into orbit. That debris gradually coalesced into what we now know as our moon. But get this, beyond just giving us the moon, that single catastrophic collision physically tilted Earth's axis. That exact tilt is the reason why you and I experience summer and winter seasons today. The rhythm of our modern years was quite literally forged in a planetary car crash.
Moving along our timeline from 4 to 2.5 billion years ago, the Archean Eon begins.
Chapter 2, The Invisible Reign of Microbes. So, the magma ocean finally hardened into a solid crust, bringing thousands of years of rain to form Earth's very first oceans. And this era presents a pretty fascinating irony. For over 1 billion years, if you stood on the surface, you'd think it was a totally dead world. The land was completely barren rock, but beneath the dark, warm, chemical-rich waves of those early oceans, life had mysteriously begun. The true rulers of planet Earth for over 1 billion years were completely invisible to the naked eye.
Dating back roughly 3.5 billion years, we find the earliest evidence of this life. They're called stromatolites, which are basically microbial mats built by photosynthetic bacteria. Now, these weren't complex creatures, they were single-celled microbes, barely more than little bags of chemistry. But they were alive, and while the continent sat there totally barren, beneath the water, evolution was quietly and relentlessly experimenting.
Spanning from 2.5 billion to roughly 700 million years ago, we entered the Proterozoic Eon. Chapter 3, The Great Oxygen Catastrophe. This is arguably the most dramatic yet least talked about chapter in all of Earth's history. Around 2.4 billion years ago, certain ancient bacteria figured out a pretty neat evolutionary trick: oxygenic photosynthesis. Basically, they started producing oxygen as a waste product. Now, to you and me today, oxygen sounds like great news, right? But back then, oxygen was highly toxic to almost everything alive on Earth.
As these bacteria multiplied, they pumped catastrophic amounts of this toxic oxygen into the atmosphere, triggering what scientists call the Great Oxidation event. It was the largest mass extinction in the history of life. Think about that wild irony for a second. Life literally breathed out so much toxic waste that it poisoned itself. Most of the organisms alive on the planet at the time simply died off. But look at the stark contrast between these two worlds. From that unimaginable catastrophe came something totally revolutionary. You see, the presence of oxygen unlocked a far more energetically powerful way to live. We start seeing the evolution of complex cells with nuclei called eukaryotes. Without this massive toxic catastrophe, oxygen-breathing complex cells would never have evolved. So the bacteria that poisoned the ancient world ironically paved the exact path for multicellular animals and eventually for us.
The stage is now perfectly set for the Paleozoic era, running from roughly 541 to 300 million years ago.
Chapter 4, The Explosion of Animals. Around 541 million years ago, we hit the Cambrian explosion. In a geologically blink of an eye window of just 20 million years, almost every major animal body plan we know today suddenly appeared in the fossil record. It was a total explosion of complexity. Eyes, legs, shells, mouths, they all evolved super rapidly. And soon after, life bravely crawled out of the oceans and onto the barren land. First plants, then insects, and then four-limbed vertebrates.
By 300 million years ago, life had completely conquered the land, and vast, massive forests blanketed the Earth's continents. And here is the crucial takeaway from this. When those massive ancient trees died, they piled up and were compressed over millions of years. That dead wood became the exact coal seams that we mine today to power much of our modern human civilization. Literally, ancient biology directly fuels our modern technology. Crazy, right?
But sadly, this era of incredible growth ended in absolute disaster. About 252 million years ago, the Permian-Triassic extinction event wiped out an estimated 96% of all marine species and 70% of land vertebrates. It was driven by massive volcanic eruptions in modern-day Siberia that flooded the atmosphere with CO2. Runaway climate change hit the planet insanely hard, leaving only a tiny fraction of life to carry on. Following that unbelievable devastation, we enter the Mesozoic era from 252 to 66 million years ago.
Chapter 5. Dinosaurs and Asteroid Impacts. This is the Great Recovery Period, and it's definitely a chapter you're familiar with. For 186 million years, dinosaurs were the undisputed rulers of the land. They were the largest, most successful land animals on Earth. But what about our ancestors during all this? Well, mammals were around, sure, but we were just small, nocturnal creatures, forced to scurry around and hide in the shadows of these giants.
Then, 66 million years ago, the universe threw a massive curveball. A 10-kilometer-wide asteroid slammed right into the Yucatan Peninsula. The impact triggered global wildfires, devastating tsunamis, and a global winter as debris completely blocked out the sun. In an instant, 75% of all species, including all the non-avian dinosaurs, went extinct. Earth's reset button was violently hit once again.
Which finally brings us to the Cenozoic era, tracing back from 66 million years ago down to just 300,000 years ago.
Chapter 6, Our Tiny Fraction of Time. With the dominant dinosaurs suddenly gone, this massive ecological void was left wide open, and that catastrophic reset is exactly what allowed mammals to finally step out of the shadows. The rise of familiar life happened rapidly in geological terms. Some mammals evolved into whales and returned to the sea. Others became horses and elephants on the expanding grasslands. Around 6 million years ago, the evolutionary lineage leading to humans split from chimpanzees, and then, just 300,000 years ago, Homo sapiens finally appeared on the scene.
Now look at this number, 10,000. Out of 4.5 billion years of planetary history, absolutely everything we consider to be human history, every empire, every scientific discovery, the invention of agriculture, the building of cities, the Industrial Revolution, all of it happened in just the last 10,000 years. On a geological scale, that is a literal fraction of a second.
When you compress the grand scale of Earth's timeline, human beings have only been around for 0.007% of the planet's total existence. We are truly the newest of newcomers.
Yet, in that unbelievably tiny fraction of time, we have fundamentally altered the globe. We've harnessed the ancient carbon of the Paleozoic and the scientific legacy of our ancestors to change the very surface and atmosphere of the world. We are already rewriting the planet's story, whether we mean to or not. So looking back at the 4.5 billion years of fire, ice, and extinction that brought us here, it leaves us with one profound question to answer. What will our chapter say? Thank you so much for exploring the terrestrial record with me today. Keep asking questions, and I'll see you in the next explainer.